The area of a trapezium is a half a plus b h. So what does all of that mean? So I'm going to label this A and this B, although you could label them the other way round, but these are the two parallel lines of a trapezium. So what we're being told with this formula is that we need to add those together, and then we're halving that because that's what it says out of the front. So we're getting the average, if you like, of A and B. And then what we've got to do, once we've worked that out, is we need to multiply it by the perpendicular height. So it is important, H must be the perpendicular height. Means it's at right angles to the base there. Use this formula, we're going to add the length of the top to the length of the bottom and halve that, and then we're going to multiply that by the perpendicular height. I'm going to show you where that formula comes from. So we've labelled this A and this B, and I'm now going to label this X and this Y. So what we can see is that B is going to be the same length as X plus, so this bit here is also A, so A plus Y. And if we just rearrange it a little bit, so B minus A will be the same as X plus Y, and that'll be useful as we proceed. So we're trying to find the area of this shape, and you'll see that what I've done is split this shape up into a rectangle and two triangles. So let's deal with the rectangle in the middle there first. So of course this is H for both of these, the perpendicular height, and the area of a rectangle is the base times the height. So the area of the rectangle is going to be A times H. So now let's look at these triangles. So they're right angled triangles, and the formula for the area of a triangle is a half times the base times the perpendicular height. So for this first one over here, we've got a half times X times H, and for the second triangle on the right hand side, it's going to be a half times Y times H. So if we add all of those together, we'll get the area of the trapezium. So we've got AH plus a half XH plus a half YH. So we're going to use this X plus Y up here so that we can get rid of that and go back to our A's and B's, because that's all we had in our original formula. And we're going to do that by just factorising out the half H here. So we've got AH plus a half H X plus Y. So now we can replace that with B minus A from up here. So if we expand that, we get AH plus a half BH minus a half AH. So we've got AH minus a half AH, so that means altogether we've got a half AH plus a half BH, and now if we factorise out the half and the H, we get our half A plus B H. The formula for the area of a parallelogram is the base times the perpendicular height. So this would be our base and this would be our perpendicular height. Remember, perpendicular means at right angles too. So let's have a look at where that formula has come from. If we look on my diagram here, we've got our base, which I'm just going to call B this time. This length here, and obviously it's also this length here. And then this would be our perpendicular height. Now you can see what I've done is I've extended over on the right hand side, and so that would also be the same height. So if we look at the shape within the two orange lines there, you can see that's a rectangle, and we know that the area of a rectangle is the base times the height. So the area of the orange rectangle that you can see there would be B times H. So all we've got to show is that the area of that rectangle is the same as the area of the blue parallelogram. So what I've done in effect is I've chopped off this section here and I've moved it across to here. So let's just prove that those two triangles are identical in size. So they're both right angle triangles, so that angle is the same. And then if we use our parallel line rules, specifically the corresponding one, then this angle here will be the same as this angle here, because those two orange lines are parallel. And in a similar fashion, this angle here must now be the same as this angle here, because if you've got two angles that are the same in a triangle, then the third one must be the same. And so both of those triangles are the exact same size, because if they have the same angles there, and we've got one length here that is the exact same side. In fact, we've got two sides, because obviously this side here is also the same length as this here. So we've got two sides the same as well. So all of that leads us to understanding that the triangle on this side is the same area as the triangle there. So by cutting it off and moving it over here to form a rectangle, I haven't cheated. And so that's why the area of a parallelogram is the base times that perpendicular height.